The Aurora Borealis is something that I genuinely want to see in real life, but until I get to do so, I guess I'm just gonna have to create my own on Blender. So in today's video, I'm gonna show you one particular method that you can use to create your own Aurora Borealis. And in case you don't want to follow along the entire tutorial and setup, you can always get the project file on Patreon or subscribe to the monthly tiers. And with that, let's actually go ahead and figure out how you can create the Aurora Borealis within Blender. The first thing that we need are the actual lines that's going to cause the Borealis streaks. So we can select the default cube and tap X and delete it. Then we have to ensure that all of the lines actually start and stay on a specific plane for the texture to work properly. So we're going to tap 7 on our numpad to go into the top view, and we're going to add in a Bezier curve. So let's press Shift A, search for curve, and choose Bezier. Now I'm going to press tab to go into edit mode, after which I'm just going to select everything by tapping A and then pressing X and choosing delete vertices. So now we essentially have a blank slate, but it's in a Bezier curve. So in the edit mode, we get all of these different options, and one of these is the draw tool. So we can select the draw tool over here, and in case you do not have these tools, you can always tap the T letter on your keyboard to actually bring it back out. Now that you have that selected, you can go ahead and draw in what your Bezier curve is going to look like, or at least the Aurora Borealis is going to look like. So maybe you could have one like that. Maybe I want all of them to be more or less close on one side and moving outward towards the edges. But yeah, maybe something like this could be good enough. Now you see, by going to the top view and pressing 7, all of them lie in the same plane. If you were to have gone to some arbitrary view and drawn in a line like that, you'll see that it's no longer on that same plane, and we don't really want this. So we're going to ensure that we don't do that. Now that you have this created, you can go back into object mode and start with the geometry node section. So let's bring our cursor to the junction of these two windows, click and drag to create a new window, and then change this from the 3D viewport to the geometry node editor. Then we'll press this plus button to create a new geometry node tree, and then we can just zoom in and bring this group input towards the side so that we have more space to work with. So the first thing that we need to do is actually resample these curves so that they become nice and smooth. So right now you see they're fairly jagged. So let's press Shift A and search for a resample curve node, plug that in right here, and now you can see how we get the segments to clearly be seen because we've reduced the count down to 10. Let's increase it to something like 500, and now it's going to be nice and smooth. However, it will never get smoother than the resolution that was set in the actual curve itself. So you have to go down to the curve properties over here and increase the resolution here as well to maybe 64, and that way it'll be nice and smooth. I'm going to keep this at 500 as well because we're going to be shifting these around to create more curves. Now that we have nice smooth curves, the next thing that we have to do is actually convert this into a mesh. So the mesh that we want to use as the profile curve is going to be aligned so that we get planes that go upwards. So let's press Shift A, search for a curve to mesh node, and plug that in right over here. And for the profile curve, search for a curve line. Now when you plug this curve line into the profile curve, we might not get exactly what we expect because we don't have the correct axis chosen. So the first thing that we have to do is select the correct axis by changing this end value from a value of 1 to 0 on the z-axis and playing around with the different axes until we get the right axis. So clearly the x-axis is still not the correct axis, so we make that back to 0, and by increasing it on the y, you can see that we are able to get it to go down as we wanted. However, I don't actually want it to go down, I want it to go up. So in that case, we're going to have to go in the negative y direction. Apart from that, I also want this to be controllable from outside, which means right from the modifier tab over here, I should be able to control the height of the Aurora based on the scene in which I'm using this. So I want to control just the y-axis as an input. So I'll press Shift A and search for a combine XYZ node, plug this vector into the end socket right there, and I can take this Y and plug that into an input, but before that I'm just going to search for a math node and change this from add to multiply, and I'm going to multiply whatever value I give as an input with a value of -1 so that it becomes negative, which means it's going to grow on the positive y-axis. Now this value is going to go into another input, and I'm going to change the name from this side panel over here from value to maybe Aurora height. So now that I have the Aurora height as an input over there, from the outside I can actually control how tall my Aurora is going to be. So maybe I'm going to give it a height of 2 meters for now. Of course, that's way too high, so I'll make it maybe a value of 1.2. Now that I have this set up, we can start giving it some more character by making sure that this top is no longer a straight plane but in fact wobbly, with some areas going much higher than others. So for that, we have to use a set position node. So let's press Shift A, search for a set position, and plug that in right after the curve to mesh. Now we're going to use the offset, and we want to offset it only on the Z value. So I'm going to search for a noise texture, and remember the noise texture is centered around 0.5. We want it to be centered around 0. So I'm going to search for a vector math node, but because I'm going to only be moving up, I don't need it to be centered around 0. It could be centered around 0.5. It shouldn't make a difference. So maybe I'll try without centering it about 0. So I'm just going to multiply it by a value of 0 on the X and the Y and a value of 1 on the Z axis so that it moves only up and down. So let's plug the color into the first socket and take this output and plug that into the offset. Now you see everything does shift up because we did not offset it. And the other issue is that the bottom position are also being affected. I want only this top edge to be affected. So we can actually do that by just ensuring that the position of the top is what is selected in this selection input. So let's press Shift A, search for a position node, and let's ensure that only the Z value is greater than some value. So let's search for a separate XYZ node, plug this position into the vector, and just check if the Z is greater than some value. So to check the greater than, we have to have a comparison. So let's search for the compare node, take this Z value, plug it into the first socket, and check if it is greater than maybe a value of 0.1, and we can plug this result into the selection. So now the bottom remains right as is and only the top is affected. Now of course this noise scale is too large. Let's reduce it to a value of maybe 2 or even lower. Let's go with maybe 1.5, and I don't want it to be this rough, so I'm just going to reduce the detail down to 0. So that looks great, and I'll leave it as is for now. The next step that we have to do is have this entire setup also move around over time. So I want to move this using a wave texture. So let's press Shift A, search for another set position node, plug that in right over here, and we're going to offset it based on the actual normals of the curve that we have. So to get the normals, let's search for a normal node, and I want the normals to be scaled based on some wave texture. So let's search for a wave texture, and let's search for a vector math node and simply plug this normal into the first socket. And remember, I want this vector math to be changed to scale, and now we can take this wave texture and plug that in right over there. Let's plug this vector into the offset for now, and you can see that we are getting these waves, but there's clearly something very wrong with them. So the first thing that we need to do is select the right axis, because in the x-axis, some areas are clearly more dense than others. So let's change this to maybe the y-axis, and now you can see they all roughly have the same density. So that means this is the correct axis. Now let's start reducing the scale so that we get very, very few waves. So maybe I think a scale of 0.3 is good enough, but the strength is way too large. So to reduce the strength of this particular operation, we can use another scale node by just duplicating this, pressing Shift D, and then reducing this scale down to maybe 0.2. And now you see we get very subtle waves within the aurora. Now by playing around with this phase offset, you can actually have these move around, which will give us that aurora feel as it moves over time. So we need this to create our loop. Now, since different people will obviously have different lengths after which they want it to loop, I want that to also be controllable right from the outside. So let's go ahead and add in 2 more slots, where the first slot is going to be the number of frames after which it loops. So the way we're going to do that is by searching for a math node, and we're going to change this from add to divide. Now we're going to take a new input and plug that into the second socket over here. And for this first socket, we're going to actually press Shift A, and we're going to search for a scene time node, and we're going to take the frames and plug that in right over here. So that way, if this input is the number of frames after which it loops, we can rename this to loop frames, and every time the frame count becomes equal to the loop frames value, the output will be 1. Otherwise, until it reaches that value, the number will be lesser than 1. And in fact, instead of using frames, maybe we could use seconds. That way it would be independent of whatever frame rate people choose to use. So I'm actually going to connect up the seconds, and instead of loop frames, I'm going to call this loop seconds. So now that I have the loop seconds sorted, I need to ensure that every time this reaches a value of 1, the output should be a multiple of 2 pi so that it can go into the phase offset. So let's press Shift A and search for another math node. This time we're going to keep it at multiply, and the second value is going to be 2 star pi, or TAU, which is also equal to 2 pi. Now we can plug this value into the first socket, and this can go into the phase offset. So now when we play the animation, every single time we reach the correct number of seconds, it's going to loop. So by default, the loop seconds is set to 0.5, so it's going to loop every 0.5 seconds. Of course, that's not what I want. Maybe I want it to loop every 10 seconds. So I'm going to change the value to 10, or in this case, the default value to 10. And over here, I'm going to have to go to the modifier property and change this loop second to a value of 10. And in fact, the default value should be changed for the Aurora height as well. I want to change the default to a value of 1, so that when you draw it by default, the height becomes 1. Now that the loop seconds is looping every 10 seconds, if I was to have the end frame at 240, which is essentially 10 seconds, it's going to perfectly loop as a seamless loop, which is exactly what we see, and that's great. But the problem is that in this case, it's actually a bit too slow. So maybe I want another control where I can speed this up a bit faster than what I'm currently getting. So I'm going to press Shift D to duplicate it, plug it in over here, and now I'm going to have this value be a speed multiplier. But remember, this always has to be an integer. So I'm going to take another input from here, plug that in right over here, and this time I'm going to call it speed multiplier, and I'm going to change the type from float to integer. So now every time I increase it at a speed of 1, it's going to be moving fairly slow, but I can always choose to change the speed multiplier to 2, and now it's going to move twice as fast, but it's still going to be perfectly looping. If I change the speed multiplier to 3, 4, 5, you can see it's moving 5 times as fast, but at the end of the day, at frame 240, it perfectly loops back, which gives me a lot of control. So I think this is absolutely perfect. Now, the next thing that I need to do is actually play around with certain values that I will require to create the perfect material. Since the material is actually going to be based on each curve, I have to store what factor along this particular curve the texture currently is, and similarly what height along this particular height, or what factor of the height the texture is present at. So I need to store those two values. So let's go ahead and figure out how we can store them. Remember, we're storing the factor for each spline, so we can actually find that using a spline parameter node. So the first thing that we need is the factor for the original curve that we have. Remember, the original curve is resampled over here. So this is still giving us each of the original curves. So we can search for a store named attribute node, plug that in right here, and we can take this factor and plug that into the value. Now the name, we can call it as Aurora factor, and it's going to be stored for every single point, which is absolutely perfect. But we also require the height as well. Now the height is actually coming in from this curve line's length that we're fixing from this input. However, we can use the same store named attribute and find out the factor along this particular curve line that we are present. So let's press Shift D, plug that in right over here, and now take this factor and plug that into the value. So if someone was to increase the Aurora height, this value will also increase, but you have to remember to change the name from Aurora factor to Aurora height. And lastly, we need to actually set the material. So let's press Shift A, search for set material, plug that in right here, and for now we'll choose the default material and start playing around with it. So the first thing that we're going to do is change the name of the default material from material to something else. Remember, in the material, because we're not using the default cube, it won't be selected, so you're going to have to use this drop down and choose material from here. We'll call this Aurora material, and then we're going to switch our viewport chaining to rendered, and in our render properties we'll switch on bloom and screen space reflections. Then we can go ahead and start playing around with the material by changing this from the geometry node editor to the shader editor. Now for the Aurora material, we're actually going to have a mixture of an emissive as well as a transparent BSDF. So let's go ahead and tap X to delete the principled BSDF, and then search for an emission node as well as a transparent BSDF. Now let's mix these two together by using a mix shader node and simply plugging this emission into the first socket and the transparent into the second socket. Now let's connect this up to the surface, and then we can see what we have. We need to make a few changes to the actual material properties. So let's go back to the material properties, change the blend mode from opaque to alpha blend, and the shadow mode can be changed to none. Remember, with alpha blend you won't get great reflections in the screen space reflections, so you might want to change this to alpha hash, but alpha hashed will require a higher number of samples to render out without noise. So it's really up to you as to what you think is needed for your scene. However, now that I have it at alpha blend, we have to start telling this mix shader which areas have to get this emissive strength and which ones have to become transparent. So we're going to do that using a few different things that are going to be multiplied together. So the first thing that I want is these edges should not just end abruptly, they have to slowly smooth out into nothing. We're going to use essentially the factor of the Aurora for that. So let's search for an attribute node, and again the name was Aurora factor. So let's type in Aurora factor. And if we were to take this factor and plug it into the factor for now, you should see that we're getting something that goes from a value of 0 to a value of 1, or a value of 0 on this side, because 0 is going to take on this first socket, which is the emission, and a value of 1 is going to take on this socket, which is the transparent. So it's going to come over here. So it's taking transparent at a value of 1, and it's all going from 0 to 1. However, I want it to go from black to white to black again. So I can do that using a color ramp node. So let's search for a color ramp, plug that in right over here. And now I can press this plus button over here to create a new slider, or I can control click to add in a new slider as well. Now, since I want it to go from transparent to visible to transparent again, I can make this white, black, black, and white, but I actually want to keep this such that wherever it's black, the output should become transparent. So I'm actually going to swap the emission and transparent nodes by taking this and plugging that into the first socket and the emission into the second. Now I'm going to go ahead, zoom in, change this to a complete white. Similarly, I'll change this to a complete white as well. So just select it and change it to a complete white. And this last slider can become a complete black. Apart from that, from linear, I'm actually going to change this to ease. And I'm just going to pull these in by the slightest amount so that they become transparent completely by the end. If you switch off overlays, you can see how they slowly fade out into nothingness. So that looks great, but I need even more control. The next thing that I need is the tips have to also fade out to nothingness. So we can do that by using another attribute which we already have stored as the Aurora height. So let's change this to Aurora height, and let's use another color ramp. So let's press Shift A, search for the color ramp, and plug the factor into the factor. And for now, let's just plug this into this factor so that we can see what we have. And the bottom seems to be transparent, but the top isn't. So that's the opposite of what we want. So let's just go ahead and flip the color ramp, and now we kind of get what we want. Let's again change this from linear to ease, and I think that looks great. Now I want both the effects to happen together. So to get both the effects to happen together, I can press Shift A, search for a mix color node, and simply plug that in just like that. I can plug whichever one into the first and second sockets. It doesn't make too much of a difference. But what I need to do is change this type from mix to multiply. So let me zoom in so that you can see it better. I'm just going to select this and go ahead and search for the multiply and change the factor all the way to 1. So now I'm going to have the tips also slowly fade into nothingness, as well as the sides also fading into nothingness. That looks great. Let's go ahead and give ourselves some more space to work with. The next thing is, obviously the Aurora isn't just going to be straight one single color. I want certain areas to have streaks of light, and the other areas should become transparent. So we're going to do that using a noise texture. So let's search for a noise texture, and also I want this noise texture to be basically vertical line. For that, I'm going to press Ctrl T to get the texture coordinate and mapping nodes and switch this from generated to object. Apart from that, remember you could change this to 2D, but the problem with 2D is that we'd have to change the looping parameters to get this to appear to move and loop, which would be a little bit more of a headache. So instead, we can just keep this at 3D, change this to object, and remember, because this object has a fixed origin, as this moves through the object, the texture is also going to change accordingly. Then we'll change the scale on the different axes to make it look like they're vertical streaks. But first, let's just duplicate this multiply node and simply take this color and plug it into the second socket so that we can actually see the streaks. Right now, you see it's just noise. So let's create the streaks by starting off and reducing the Z value to maybe something like 0.1. So now we get clear streaks, but they're not contrasty enough. One thing that you could do is maybe reduce the scale a bit. So maybe I'll change the scale to 2 or maybe a value of 3. I'll keep the detail as is, but I'll search for another color ramp, or I can just duplicate one of these color ramps by pressing Shift D, and while hovering over the color ramp, I can actually press the backspace to reset the color ramp node. Then I'll just bring in the black a bit and I'll bring in the white a bit, and that should just give me some more contrast. So I think that looks good. Similarly, I'll change this from linear to ease, and that looks great. Now when I was to play the animation, you can see how they are also changing over time because the texture is in 3D. So that looks great, and I think that's what I'll leave it at because it looks exactly like the way I want it. However, there's one slight issue, and that is that areas where there's sharp turns, it becomes a little too bright. So for that, we're gonna actually use another mix RGB node set to multiply, and this time we're gonna actually search for the layer weight node, which will give us some values towards these particular corners. If we were to currently just Control Shift click it with the node wrangler enabled to see what it looks like, you can see how areas with more curves are looking more white. Let's first change this from Fresnel to facing, and that looks a little bit more like what I want, but I'm just going to start increasing the blend or decreasing it to see exactly what I have. So I think I want the exact opposite of this. So I want these areas to become black and these areas to be completely white. So I'll search for another color ramp node, or I can just duplicate this one because it's already inverted as well. And then with this, I can plug that into socket B of the multiply node, and then Control Shift click the mix shader with the node wrangler enabled to connect it to the material output. Now I think that just looks a lot softer around the edges, but of course you can play around with how soft you want to make them and things like that. And you can also just reduce this factor in case you feel like the strength is a little too much. Once you're happy with the way everything looks, you can play around with the actual emission. So back in our render properties, since we have bloom enabled, we can increase the strength to actually start getting some bloom effect. Remember, as you play around with this strength, you might want to play around with the actual amount of areas that become transparent based on your personal preferences, but I think I'll leave mine just like this for now. For the color, however, I'm gonna actually use a slightly different technique, which is using a hue saturation value node. What this does is allows me to actually control one specific color and give it a few shades here and there. So if this was, let's say, for example, green, I can change this in two ways. The first way is searching for a noise texture and plugging that noise texture into the hue, and just like before, using another mapping node with this object coordinate plugged in right over there. And remember, the scale has to be really low on the Z to make vertical stripes. You can actually get vertical stripes of different colors. You can always reduce the detail, reduce the scale, and in case this is changing the hue too much, remember, you can always search for a color ramp node, plug that in right here. So instead of going from a value of 0 to a value of 1, you can actually select this and change the value from 0 to maybe 0.45, and then have this value go to a value of 0.55. So that way you're still getting a variation in the colors from this, but just a very subtle amount. You can reduce this as much as necessary, so maybe 0.52, but again, it's really up to you. Now I actually want all of these properties to also be controllable from within the actual modifier right here. So there's actually one more thing that we could do to create that, and that is using some more attributes. Of course, we could add in attributes here and have these controls from the actual material, but I feel like it's always simpler to have everything present in one particular panel. So I'm going to switch over to my geometry node editor, and I'll just store two more attributes so I can store them right at the start. Let's bring this over to the side, and maybe I'm going to store 3 different values. So let's press Shift D to duplicate the store named attribute node, and I'm going to change this from float to color. Let's just plug this in over here, and instead of from every point, I can store it for every spline, because that way it just reduces the number of points stored by Blender. Now let's go ahead and plug this in, and let's call this as color. The default, I'm going to give it this greenish value itself, something like that, and let's go ahead and select it over there as well. Next, let's just duplicate this once again, and this one I'm going to call Aurora Color. This one is going to be a float, and it's going to be color variance. Let's plug that in right over there, call it color variance, and then let's just search for one more, and this time call it color noise scale. So let's take this, plug it in right over there, and I'll call it color noise scale. So now that we have these 3 present right here, I can go ahead and switch over to my shader editor. For the color, let's search for an attribute node, call it Aurora Color, and plug this color into the color right there. So now I should be able to control what the base color is right from here, which is perfect. That looks great. Now I need the variance. So remember, the variance was essentially what happens over here. So I'm actually going to change this to a complete black, change this to a complete white, and now press Shift A, search for another attribute node, call it color variance, and now you see the color variance is going to be a slider over here, and I want it to equally space out from 0.5 lower and higher. So the way I'm going to actually do that is by searching for a map range node, plugging that in right over here, and I'm actually going to search for a math node, which is going to be kept at add, and I'm going to essentially do 0.5 plus this value and 0.5 minus this value. So let's actually keep this down here, press Shift D, this time change it to subtract, and it's going to be 0.5 minus this value. Now this value is the 2 min and this value is the 2 max. So now if I was to just increase the color variance, you can see how we get different variance in the color, and we can go as crazy as we want. That looks absolutely perfect. Let's keep it at a color variance of 0.01 or maybe 0.2. 0.02 looks good in this particular situation, but again, depends on the color. But yeah, I think that looks great. The next thing that we wanted was the color noise. So that is essentially essentially the scale of this particular noise. Let's see, if we were to change this to some area where we can clearly see the variance, let's increase the variance so that we can see it even more. If we play around with this scale, you can see how it's changing. So that is going to be the color noise. Let's actually reduce this from 0.1 to 0.05 so that it's even longer. And for this scale, search for another attribute node or press Shift D on this attribute node, change it to color noise, and plug this color into the scale right over there. Now let's just increase this, and it's doing nothing because we're using the color. I should have been using the factor. Let's plug that in right over there. It's still doing nothing because we actually have it as color noise scale. So now you can actually control the scale from here as well. So I think that looks great. Let's ramp up the scale, reduce the color variance, and yeah, now you can actually get all of the controls right from here. You can choose how many seconds after which it loops. You can choose how fast it moves around. I actually think we should have one for how much this thing moves. So let's go ahead, shift over to the geometry node. Let's see, the amount by which it actually moves is based on this scale over here, and even the scale of the wave texture should be an input. That feels like there's quite a few inputs, but I think it is necessary for somebody that just wants to have whatever they want. So let's go ahead and plug this scale into an input, change this to Aurora Displacement, we'll call it Aurora Wave Scale, and I want this to be much higher, so maybe just after the Aurora height. So to move that, we can just click and drag it right there, and similarly I need one for this, which is going to be the Aurora Displacement. So let's plug that into another socket into the input, call this Aurora Displacement, we'll call it Wave Displacement, and again just shift it up right after there. For the default of the color variance, I want it to have a default of 0.01, and the color noise scale, I want it to have a default of a value of 1. So that way we have defaults set, we have the entire node set up, and that works absolutely great. You can always keyframe these values so that over time it actually moves to different colors, and you can have it looping as well. It's again all up to you and what you think suits your scene. Remember, this also kind of looks pretty decent as some fire. I think maybe we could create a fire setup as well by doing something similar to this. But until then, let's go ahead and just create the rest of the scene. This portion is going to be heavily sped up, so hopefully it won't be too hard to follow along. The first thing that I want to do is create a base plane on which everything is going to reflect. So I'll press Shift A, search for a mesh plane, and I'll scale this up. Remember, as long as you have the Aurora selected in object mode, you can actually move it around and it will not mess around with any of the textures that you've created. However, if you were to actually change it in edit mode, then it would be an issue because your texture coordinates would not work properly. So ensure that if you do any movements, you're doing it always in object mode. Similarly, after you've done any movement, if you were to go into edit mode and try and add in another curve, it'll actually mess around with the texture coordinates. So do not do that. If you want to add in a new curve, make sure that you place your 3D cursor at the origin, go to the top view once again, edit mode, and then draw in just like that. That way you'll have it drawn in the correct place. In my case, I did not place the cursor to the correct position. I should have pressed Shift S and then chose cursor to selected, and then I should have gone to 7, tab, edit mode, draw your curve, tab, object mode, and now it should be wherever you want it to be. However, let's just Control Z the last few of those, and that's good enough. Now I don't need this light, so let's select it, tap X, delete it, Shift S, cursor to world origin. Now this particular plane, I want this to be some sort of water. So let's go and switch this over to the shader editor, press this plus button to create a new object. It's going to be completely metallic with the roughness down to something like 0.2. And for the normal, we're going to search for a bump node. So let's press Shift A, search for bump. Let's plug that into the normal, but for the actual height, we're going to use some noise texture. You can literally use whatever you want, but in my case, I'm just going to use a simple noise texture. Now let's just press GZ to lift it up or down based on the amount of distance you want between your Aurora and the floor. And to actually get the nice reflections, you can go ahead and change this from alpha blend to alpha hash. So now you can see you do start getting some screen space reflections right over there. Let's just go ahead and increase the scale of the noise texture for the bump node. So something like that should be fine. And of course, if you want this to move over time and you want it to be looping, you can duplicate it, change this to 4D, and you can play around with the W values. Both of them have to be at 4D. You have to mix them together using a mixed color node, keyframe the values accordingly. We've done that in multiple previous tutorials, so maybe you could check out this video over here in case you want a tutorial where we've gone about how to actually loop noise texture like that. Now the next thing that we need to do is change the base color to maybe a bit bluish so that it's a little bit more like water. And maybe for the background, I want it to be completely black when it comes to the actual light sources. So that looks great, but I do want there to be some sort of nebula. So we've already done a nebula in this particular tutorial over here. So I think you can definitely check that out if you want. But for today's video, I'm just going to add that in from my asset browser. Now that I've added it in, I can just remove that, take this shader and plug that into the world output. So now I have a nice nebula shader in the background, but it's also giving light to my water. I did not want that. So for that, I can again use the mix shader node. I can use a light path node. And in case you don't know how the light path node works, you can check out this video over here that explains it in the best way that I could. So now let's have another background node changed all the way to black. Plug this in right here. Use the is camera array to plug that in over there. And I'll plug this background into the second socket. Now that is the exact opposite of what I wanted, because everything is being lit by the nebula shader, but the camera is seeing black. I want it to be the opposite, so I'll plug this into the first socket and the nebula shader into the second socket. There we go. Now the thing is, as we look further into the distance, I want the horizon to actually become dark and mix in with the sea. So I'm actually going to have to go into my nebula shader, and as we've done multiple times before, we have to multiply everything with a gradient texture. So if we press Shift A, search for a gradient texture, Control Shift click to preview it, you should be able to see what the gradient texture looks like. We can always press Shift A and search for the texture coordinate and mapping nodes, or with the node wrangler enabled, we can press Control T to get the texture coordinate and mapping nodes. Remember, again, if you feel like doing all of this is too much, you can always download the completed blend file as a product from my Patreon store, in which you'll get the animation as well with a couple of wallpapers and the blend files. So it's definitely worth checking out if you do not have the time to set all of this up yourself. Then we can just rotate this about the y-axis so that you see you have the black right at the bottom, and once you have that, you can multiply this in with whatever color you want it. So the way we're going to multiply this is by removing this over here, using another mix shader, plugging it in right there. This shader is going to remain blank so that it's black, and then just plug this color from the gradient into the factor. Now I feel like this is the opposite, so let's plug this into the bottom socket, and now you are able to see the stars towards the top, but I want it to be a lot lower. So let's go ahead and just play around with the X position, and it seems like along with the X position, we're going to have to play around with the scale of the actual gradient as well. So that way, now you can see as we go towards the horizon, it just goes into complete darkness, which is exactly what we wanted. So now we can zoom in once again and go back to where our camera would be positioned, which is probably somewhere like that. Now the next thing that we need are some other objects to be present here. So let's press Shift A, search for another plane, and this time I'm going to switch over to the geometry node editor. Of course, let's just see where the plane is. It's present right there. Let's scale it up, add in a new geometry node tree by pressing that plus button. I'll press period on my numpad to centralize the nodes. In case that doesn't work, tap A to select everything and then period to centralize them. And now I'm just going to use a very simple technique, which is displacing it with some noise. First, I need to subdivide the mesh. So let's search for a subdivide mesh node, plug that in, and let's increase the level up to something like 5. Then let's press Shift A and search for a set position node and set the position based on some noise. So let's search for a noise texture and plug this into the offset. Now it goes right up. That's not what we want. So let's search for some vector math nodes, plug that in right here, change it from add to subtract, and subtract a value of 0.5 on all the axes. Then let's scale down the effect by just shifting these over to the side, searching for another vector math node. So Shift D, this time change it to subtract or scale, and scale it down to maybe 0.1, or just scale it a little higher. It doesn't quite matter. Let's reduce the scale on the actual noise texture. So maybe something like that could create the glaciers. Let's go back into object mode so that we see what we have. And yeah, that looks great. Let's just increase the subdivisions level. That looks cool. Let's increase the level maybe to 8, and let's just increase this scale as well. So yeah, something like that could be good enough. It's really up to you and what you personally think the scene should look like. Let's give this a new material by pressing Shift A, searching for the set material node, plugging that in right over there, and then giving a new material over here. Let's call it maybe glaciers, and choose that right over here. Now for the glaciers, I'm just going to make it completely metallic so that they are reflective. Change it to a blue, reduce the roughness a bit. Maybe I'll add in some bump as well, just like I did for the actual water. But essentially, once you place the camera, you should be good to render. To place the camera, you can select the camera and if you just like the position you're currently at, you can press Ctrl Alt 0 to snap the camera to view. In my camera settings, I'm just going to go to the viewport display and increase passbar 2 all the way to 1 so that I don't see anything outside my camera view. Then I can take this and just scale it up or just rotate it a bit on the x-axis so that it looks a lot more exaggerated. I think that's how most of them look. I'll move it on the local y-axis as well, just like that, and that looks great. I might change this back to alpha blend before rendering, and I might artificially light this up with some other lights in the scene. But yeah, there's actually a lot more that you could be doing, but I feel like this tutorial's already gotten fairly long, so I'm gonna leave it just like this. Once you're happy with the way everything looks, you can go ahead and just render out the animation. I hope this was a fun tutorial for you, and again, this is just one method of creating the Aurora. I will be releasing a few other methods that I was testing out on creating different styles of Aurora at least. So definitely stay tuned for that, and in case you liked this video, do let me know because I love creating space related videos and cool things just like this, but I feel like many a times those things end up becoming a bit longer like this video did. I don't know how much people enjoy watching longer form tutorials like this because at the end of the day, whether my video is 4 minutes long or 20 minutes long, my audience retention is still gonna be 1 to 2 minutes at most. So most people do not watch videos for more than 2 minutes on my channel. So I feel like making shorter videos itself benefit more people, but I don't know if that's actually the case. So let me know what you would like to see and if you're okay with watching slightly longer tutorials just like this. I do have videos in line for creating maybe the Chladni plates as well, or Chladni plates, not sure how you pronounce it, but that will also take a little bit of math and setup time for the tutorial. So in case you all are interested in watching videos like that, let me know and I'll create those as well. I did try separating out videos into part 1 and part 2 so that it's not a hassle on me or the viewer, but those videos seem to not do well compared to any of my other videos. So I'm trying to make sure that if I do create a tutorial, I create it as one single video itself. So let me know what you guys think and I will definitely cater to that particular type of video. Since I plan on making a few slightly more complex videos as upcoming videos, I'm thinking I'll post once every 2 to 3 days, because if I post every single day, again, I feel like there's an oversaturation of content, so the number of views seem to drop drastically every single video I release on a daily basis. So let me know what you think the right way to move forward is, and until my next video comes out, thank you so much for watching, keep creating, and don't forget to stay creative.